Hello everyone. In this video, we will solve 12 important numericals on machines. These questions are based on the 3 key formulas for mechanical advantage. So by the end of this video, you will be much more confident in solving exam questions. Let's get started. Let's have a look at question number 1. The question says a crowbar of length 120 centimeter. So first we have to know that crowbar belongs to class 1 lever. If you remember this, you can solve this very easily. So in a class 1 lever, the fulcrum is in the middle. So we will first draw it like this. That this is the fulcrum. Here there is load and effort. Now, crowbar of length 120 centimeter, which means the total length is 120 centimeter. Has its fulcrum situated at a distance of 20 centimeter from the load. So, fulcrum and load, the distance is 20 centimeter. Calculate the mechanical advantage, which means distance between the fulcrum and the effort will be how much? 120 minus 20, which is 100 centimeter. You have to calculate the mechanical advantage. So, mechanical advantage equals to effort arm, length of effort arm upon length of load arm. We will write that. Length of effort arm upon length of load arm. And see, effort arm is the distance between effort and fulcrum, which is 100. And load arm is between load and fulcrum, which is 20. So we will get 5, which means the mechanical advantage is 5. So mechanical advantage is 5. I hope it is clear. Let's see the next question. Now, question number 2. A pair of scissors has its blades 15 centimeter long. Again, scissors, it is a class 1 lever. So, we will draw like this. And its blades are 15 centimeter long while its handles are 7.5 centimeter long. What is the mechanical advantage? So blades means, so this is the fulcrum, here is the, let's say, load, and here is effort. So blades is where the load is. So therefore, when they are telling that the blade is 15 centimeter long, which means the load arm is 15 centimeter long. So this is 15 centimeter. And handles, their effort is applied. So handles are 7.5 centimeter long, which means effort arm is 7.5 centimeter. And mechanical advantage. So mechanical advantage is equal to length of effort arm upon length of load arm. So effort arm is 7.5. And load arm is 15. Just calculate and you will get. So, mechanical advantage will come 0.5. Every time you have to draw the diagram correctly and look at what is the value, what is the length, effort arm and what is load arm. And just put the formula, length of effort arm upon length of load arm, and you get it very easily. Let's see the next question. Now, question number 3 says a force of 5 kgf is required to cut a metal sheet. Shears is something that you cut metal with and it looks like scissors only. So, it is also a class 1 lever. So, a force of 5 kgf is required to cut a metal sheet. A shear used for cutting the metal sheet has its blade 5 centimeter long. So, blade is 5 centimeter long, which means load arm is 5 centimeter. So, we will again draw, this is the fulcrum. So, we have to know that shears is a class 1 lever. This is fulcrum, load and effort. When they are telling that blade is 5 centimeter long, which means the load arm is 5 centimeter. We can write also that load arm is equal to 5 centimeter. And while its handles are 10 centimeter long, so handle is 10 centimeter long, which means the effort arm is equal to 10 centimeter. Now they are telling that what effort is needed to cut the sheet. We have to calculate the effort. So since we know the load arm and effort arm, first let's calculate the mechanical advantage. So mechanical advantage is equal to effort arm, which is 10, upon load arm, which is 5. So we are getting 2. Mechanical advantage equals to 2. But they have asked us what effort is needed. Effort we have to calculate. So what we will do, we also know that mechanical advantage is equal to load upon effort. And load they have given, force of 5 kgf is required to cut a metal sheet. So when we are cutting the metal sheet, that this much is the force required, which is the load is this. So load is 5 and the mechanical advantage is 2 they have given. We don't know the effort. So we will write 2. Mechanical advantage we calculated 2. 2 is equal to 5 upon effort. So effort, therefore effort will be how much? 5 upon 2, which will come 2.5 kgf. Everything is in kgf. So kgf. And we are done. Now question number 4 says, figure this shows a lever in use. To which class of lever does it belong? So we can see fulcrum is in the middle, load and effort are on the either side, which means it belongs to class 1 lever. Now, if AB is equal to 1 meter, so AB, that means total length is 1 meter, and AF is 0.4 meter. So AF is distance between the load and the fulcrum, which means load arm. Load arm is 0.4 meter. So what is effort arm? Effort arm total is 1. So then if this is 0.4, so this will be 1 minus 0.4, which will be 0.6 meter, which means effort arm is 0.6 meter. Now they are asking find its mechanical advantage. So mechanical advantage is equal to 0.6 upon 0.4. Just calculate and get the answer, which is actually 6 upon 4 equals to 1.5. So we got the mechanical advantage and as 1.5. Now calculate the value of effort. They are also telling that what is the effort. Now we will use the formula mechanical advantage is equal to load upon effort, because we have already got mechanical advantage. So we will write mechanical advantage is equal to load upon effort. We got it as 1.5. We can use that. So 1.5 is equal to load. Load is 15 kgf. So 15 upon effort we have to calculate. So effort will be equal to 15 upon 1.5. Just calculate. Which is 10 kgf, and we are done. So we are getting the effort as 10 kgf. This is how we can calculate. Let's see the next question. Now question number 5 says a man uses a crowbar. Again crowbar is class 1 lever. Every time we have to remember. Crowbar of length 1.5 meters. So let's say I am drawing. This is fulcrum, load, effort. Crowbar's length is 1.5 meter, which means this whole distance is 1.5 meter. To raise a load of 75 kgf. So load is 75 kgf. 75 kgf. By putting a sharp edge below the bar at a distance of 1 meter from his hand. His hand, that means there is the effort he is applying. So that distance is from the fulcrum. So what is this 1 meter that we have to understand? That places putting a sharp edge below the bar at a distance of 1 meter from his hand. Which means distance between the fulcrum and the effort, that is 1 meter. So this distance is 1 meter. And if this is 1, which means this distance is 0.5 meter. Now what? Now calculate the load arm they are asking. So load arm is distance between load and the fulcrum, which will be 0.5 meter. Now calculate the effort arm. Effort arm is distance between effort and the fulcrum, which is 1 meter. So this is 1 meter. And now mechanical advantage. So mechanical advantage is equal to effort arm upon load arm. Actually length of effort arm by length of load arm. So effort arm is 1 and load arm is 0.5. So which is 1 upon 0.5. 2. So we are getting the mechanical advantage as 2. And now effort needed, we also have to calculate the effort. So we will apply that mechanical advantage is equal to load upon effort, which means 2 is equal to, load was given to us 75 upon effort. So effort will be how much? 75 upon 2, and get the answer. 37.5 kgf is the answer. We will get as the effort, and we can solve. So in every question, what we are using is mechanical advantage is equal to length of effort arm upon length of load arm, and mechanical advantage is equal to load upon effort, and very simply we got all the answers from question number 1 to 5. Let's see question number 6. Now question number 6, a pair of scissors, which means class 1 level, is used to cut a piece of cloth by keeping it at a distance of 8 cm. So cloth is kept at a distance of 8 cm from its rivet, which means load arm is equal to 8 cm. So if we draw, this is the fulcrum, this is the load, this is the effort, and load arm is given to us as 8 cm. And applying an effort of 10 kgf. How much effort we are applying? 10 kgf. By fingers at a distance of 2 cm from the rivet. So fulcrum, this distance is 2 cm. And find the mechanical advantage of scissors. So mechanical advantage is equal to length of effort arm upon length of load arm. Effort arm is 2 and load arm is 8. So 2 upon 8. So we will get it as 0.25. Now mechanical advantage is equal to load by effort. We already got it as 0.25. So 0.25 is equal to load by effort, and effort is 10 kgf. So 10. So load will be how much? 0.25 into 10, which is 2.5 kgf. Right? Now, they are also asking, how does the pair of scissors act as a force multiplier or as a speed multiplier? How it is acting? So here we are seeing that mechanical advantage is less than 1. So the scissors, it acts as a speed multiplier, not as a force multiplier. Let's see the next question. Now question number 7. A 4 meter long rod of negligible weight is supported at a point 125 centimeter from its one end, which means that, let's say this is the rod. Its length is 4 meter. 4 meter. So the distance from here to here, it is 4 meter. And it is supported at a point 125 centimeter from its one end. This is one end, and let's say this is 125 centimeter. So this distance is 125 centimeter. And it is supported, which means the fulcrum is here. At a point, and a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. So this is the, so first of all, this is 125 centimeter and this is 4 meter. 4 meter means 400 centimeter. Now, this is the fulcrum and the load. We will come to that, but now, what is this distance? Let's calculate. So if you do 400 minus 125, you will get 275. So this distance is 275 centimeter. Now they are asking that, and a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. So this is the short arm, this is the long arm. Load is suspended 60 centimeter from the support, which means here is the load. Let's say here is the load. And this load is 18 kgf. So this load is 18 kgf. And the distance is 60 centimeter. So this distance is 60 centimeter. This distance is 60 centimeter. Now they are telling, if a weight of W, so here the question is not very clear. So the question says, if, here it is, if a weight of W is placed at a distance of 250 centimeter, it is actually 250 centimeter from the support on the longer arm, find W. So this is the long arm, and what we are doing, we are putting a weight W at a distance of 250 centimeter. So let's say this is 250 centimeter and here is a weight W and this distance is 250 centimeter. Now the question says find W. We have to find out how much W is. So we will apply that load into load arm is equal to effort into effort arm. We will apply the principle. So total clockwise moment is equal to anti-clockwise moment. So this weight is 18 kgm and this distance is 60 centimeter. So we will write 18 into 60 is equal to, this side the moment is W into 250. This distance is 250. So we will write W into 250 and solve W, get the value of W. W will be how much? 18 into 60 upon 250. So if we solve, we will get this as 4.32 kgf and we have got the answer of W. W is how much? 4.32 kgf. Now they are also asking if a weight of 5 kgf is kept to balance the rod, find its position. Now we don't know that where that weight is, but we are putting a 5 kgf and we have to find out the position. So which means this is the scenario. Now the weight 5 kgf. So the second question, for the second question what we will do this load which is 18 into 60. 18 into 60 equals to that weight. Where it is we don't know. That's what we have to calculate, but that weight is 5 kgm. So 5 into that distance we have to calculate. So that distance, let's say it is x. So x what we will get? 18 into 60 upon 5. 5 12 times. And if you do 18 into 12, let's see what we get. We will get as x is equal to 216 centimeter. And in meter if we calculate, we will get 2.16 meter. So that weight which is 5 kgf, if we have to hang it, where should we hang it? We will simply apply total clockwise moment, anti-clockwise moment. So 18 into 60, this 18 into this distance 60, and where to hang that weight? So that weight is W, that weight they have given 5, so 5 into that distance, let's take it as x. And we calculate, we get 216 centimeter, or if you calculate in meter, you will get this. Then they are asking to which class of lever does it belong. So we can see fulcrum is in between and load and effort are on the other side. So basically fulcrum is in the middle, so it will be class 1 lever because fulcrum is in the middle. And that's how we can solve it. Let's see the next question. Now question number 8. It says a lever of length 9 centimeter. So this is the lever, its length is 9 centimeter. Has its load arm 5 centimeter long and the effort arm is 9 centimeter. So effort arm is 9 centimeter, which means the fulcrum is at one end and the effort is at the other end. And therefore, we can say that the effort arm is 9 centimeter and load arm is 5 centimeter, which means load is somewhere over here, distance between fulcrum and the load. So this is the load, this is 5 centimeter. They are telling to which class does it belong. Now here load is in the middle, which means it belongs to class 2 lever. So the answer will be class 2 lever. Now draw the diagram of the lever showing the position of fulcrum and the directions of both the load and the effort. So see, so this is the diagram that you will draw. And what is the mechanical advantage? So mechanical advantage will be how much? Mechanical advantage is length of the effort arm, which is 9, upon length of the load arm, which is 5. So if you calculate, you will get 1.8. Then they are asking, so mechanical advantage you got, and they are also asking velocity ratio if the efficiency is 100%. So we have to remember the formula that mechanical advantage is equal to velocity ratio into efficiency. Now they are telling efficiency is 100%, which means we will take efficiency as 1. So mechanical advantage we got 1.8 is equal to velocity ratio into 1, which means velocity ratio is also 1.8. So velocity ratio will also come 1.8. And they are then asking what will be the mechanical advantage and velocity ratio if the efficiency becomes 50%. So if the efficiency becomes 50%, velocity ratio does not change. It will remain 1.8, but mechanical advantage will change. So we will write that when efficiency equals to 50%, then velocity ratio, it does not change, it remains same. So it will be 1.8, but mechanical advantage will be 1.8 velocity ratio into efficiency. So 1.8 into, it is 50%, so we will take 0.5. And now if you multiply, you will get mechanical advantage as 0.9. So this is the mechanical advantage you will get, and velocity ratio will remain same. So you have to remember that the velocity ratio does not change, it remains same. And when the efficiency changes, mechanical advantage will accordingly change, right? Let's see the next question. Let's look at this question. Figure shows a lever in use. To which class of lever does it belong? We can see load is in between, fulcrum and effort on the other side. So this belongs to class 2 lever. FA is 80 centimeter. FA, distance between load and fulcrum, which means load arm is equal to 80 centimeter. And find AB is 20 centimeter. AB is distance between the load and the fulcrum. So this is 80 and this is 20. Now, effort arm is distance between the effort and the fulcrum, which means effort arm is 100 centimeter. So effort arm is 100 centimeter and they are telling us to calculate the mechanical advantage. So mechanical advantage will be how much? 100 upon 80, which is effort arm upon load arm, length of effort arm upon length of load arm. And just calculate, you will get it as 1.25. Now they are asking calculate the value of E. Effort we have to calculate. So how much is the effort? So mechanical advantage equals to load upon effort. We got mechanical advantage as 1.25. So 1.25 is equal to load, which is 5 upon effort. So effort will be how much? 5 upon 1.25. Just calculate. So we will get effort as 4 kgf. And this is how we can calculate the effort, the mechanical advantage and this. So every time you have to draw, the diagram was given over here, but you have to understand the length of the effort arm, length of the load arm, calculate the mechanical advantage and use it to calculate the effort. Right? Let's see the next question. Now question number 10 is, see this is a wheelbarrow and we know wheelbarrow belongs to class 2 level. So shows a wheelbarrow mass 15 kg. So mass of the wheelbarrow is 15 kg. It carries a load and load is 30 kgf. It's the center of gravity at A. So here is the center of gravity. Point B and C are the center of the wheel. And this is 20, this is 40, we can see. And now they are telling, find the load arm. So load arm is the distance. This is the, here the load is. Distance between the load and the fulcrum. So this is here the load is and this is the fulcrum. So this is 20 centimeter is the load arm. And therefore, the load arm that they are asking, this will become how much? 20 centimeter. Now effort arm. Effort arm is the distance between the effort and the fulcrum. So this is 40 plus 20, which is 60. So effort arm will be how much? 60 centimeter. And now they are telling number C, the mechanical advantage. So mechanical advantage is equal to effort arm upon load arm, which is 60 and load arm is 20. So we will get it as 3. We got the mechanical advantage and now the minimum effort, we have to calculate the effort. So mechanical advantage equals to load upon effort and we got that as 3. How much is the load? Load is the total weight of the wheelbarrow and plus the weight that it is carrying. So 15 kg means 15 kgf and plus 30 kgf, which is 45 kgf. So 3 is equal to load is 45 upon effort. So effort we will get 45 upon 3, which is 15. So effort will be 15 kgf. And it's done. This is how you can solve it very simply. Let's see the next question. Now, question number 11 says that use of a lever, we can see effort is here, load is here, and the fixed means here this is the fulcrum. So which means this is a class 3 lever. So this is a class 3 lever because we can see effort in the middle. Now they are telling state the principle of moments as applied to the above level. So what is the principle of moments? So principle of moments is total clockwise moment is equal to anti-clockwise moment. In this case, so what will be the clockwise moment and the anti-clockwise moment? So this is the fulcrum, here is the load. So load into load arm, load is 50. So 50 into load arm is how much? So this whole distance they must have given FA is equal to FA is 10 centimeter and AB is 490 centimeter they have given, AB. So this is 10 and this is 490. This distance is 490. Now they are asking that state the principle of moment. So principle of moments is load into load arm. Load is 50 and load arm is 490 plus 10, which is 500, is equal to effort into effort arm. And effort arm, so effort is not given, whatever is the effort, that effort into effort arm, which is 10. This will be the principle of moments. And now they are asking to which class of lever does it belong. So it belongs, effort is in the middle, so it belongs to class 3 lever, which we already said, and give an example of this class of lever. You can give any example, tweezer, fishing rod, anything that you remember you can write. Now they have told calculate the mechanical advantage. So mechanical advantage will be how much? Effort arm upon load arm. How much is the effort arm? Effort and load, distance is 10. And load arm, so load is here and fulcrum is here. So 490 plus 10, 500, which means 1 upon 50. So mechanical advantage is 1 upon 50. And now they are asking minimum effort required to lift the load. We have to lift the load, and what is the effort required? Same formula we will use, that mechanical advantage is equal to load upon effort. Mechanical advantage we got 1 upon 50 is equal to load is 50 and effort we have to calculate. So effort will become 50 into 50, which is 2500 Newton. And see, we got it in the same manner like we did all the questions. Simple, very easy. I hope it is clear. Let's see the next question. Now this is the last question, question number 12. A fire tongs has its arms 20 centimeter long. Now we have to remember that fire tong is a class 3 level. So we will first draw and we will write effort in the middle. One side is load, another side is fulcrum, because it is a class 3 level. Fire tong has its arms 20 centimeter long. It is used to lift a coal of weight 1.5 kgf. So load is 1.5 kgf. By applying an effort at a distance of 15 centimeter from the fulcrum. So fulcrum and effort, this distance is how much? This distance is 15 centimeter. And the previous that they said that fire tong has its arms 20 centimeter long, which means that this is 20 centimeter. And we have to find the mechanical advantage. So mechanical advantage is equal to effort arm, which is 15, upon load arm. So mechanical advantage is effort arm by load arm. Effort arm is 15 and load arm is 20. So we will get 0.75. This is the mechanical advantage. And now we have to calculate the effort needed. So let's calculate mechanical advantage equals to load upon effort. Mechanical advantage is 0.75 equals to load, and load is, they had given 1.5. So 1.5 upon effort. We just have to calculate it. So effort equals to 1.5 upon 0.75. And just calculate, we will get the answer. So effort is equal to 2 kgf. And we are done. I hope you found these numericals easy to understand and helpful for your exams. If you enjoyed this video, please like, share and subscribe for more ICSE Physics lessons. Thank you for watching, and I'll see you in the next video.